Okay, let me introduce myself. I'm Morrone, I work for Anton Par, and I'm in charge of the scientific support and I'm manager for instrument of indentation, scratch test, and tribology. And today I will present some work with the scratch tester and indentation tester. And we did this work with Professor Hulme from MIT. And in this work, we talk about fractal toughness, describe the ability of the material containing fractures, this fracture. And usually, the standard test needs a pre-crack and are done with 3-point bending, 4-point bending, and traction test. And now we want to show that also the use of scratch test can be a good choice. The challenge is to connect the scratch response to a quantifiable material fracture properties. And this is difficult because with the scratch test we have several length scales coming from nanometer with the nano scratch test that can be used to analyze a very thin layer up to millimeter and high load times hundreds of newtons with the Revit scratch test that is a macro scratch test. Then we have to face with the three-dimensional probe shape and a variety of deformation patterns inside the sample. So to link this property to the probe shape, we use the strain energy related, that is the energy required to create a unifracture surface. So this is linked to the scratch probe shape function and to the force applied and to the characteristic of the material. And we use that in a way in which we, in the onset of the crack progression, in which we have a fracture criterion with G is a G fracture and is connected with the plane strain fracture toughness. In this way we can link the fracture toughness to the scratch probe shape function. This function is presented is for a Rockwell tip, and here we have the conical part of the tip, a parameter to the spherical end tip, and a part due to the tip blunt. So now we have to find these three parameters from a tip calibration, and we choose an homogeneous linear elastic isotropic mechanical behavior material that is the Lexon 9034 because we know very well the fractal toughness of this material. So this is a scratch done with our instrument. We record the penetration depth, the measured force during the applying of the force, and for example also the residual depth after the scratch and the frictional force. Then we plot the value of the scratch probe shape function. Some delay in function of the depth of the scratch, and we found the three parameters. Then we do another scratch in copper, and also here we do applied force, the penetration depth and frictional force, and then we plot the force again over the radius of the tip against the shape of our indentation shape, and we found a correlation, a linear correlation that is proportional to the fracture toughness. So we can extract the fracture toughness, and we found a value of fracture toughness very close to the no1, and this is for the copper. So also Professor Hulme found with a soda lime glass and Pyrex same results. These are results that are very good agreement with literature. And so this is a way to evaluate fracture toughness. And the important thing is the scratch test does not require any initial notch or pre-crack or fatigue on the sample. And in the same way in which we have to choose the initial notch with macro test, here we have to choose the tip geometry to achieve a fracture-driven state that enables to prove the fracture resistance. And then the fact that with a stretch test, we make it possible to sample the fracture property in different locations in material, so we can do also a test on homogeneous, and with minimal cost and use a limited material supply. So another work also done with Professor Hulme is on concrete and is about creep. The concrete is a mixture of water, clinker mixture, and aggregates, and the mixture proportion is linked with the mechanical performance. To test the mechanical performance, we require times, sometimes years, and are highly costly tests. With a nano-hardness test in our chamber with temperature control and humidity relative control, it will permit you to test the concrete in different temperature and relativity humidity ambience. We can do the test on the calcium silicate hydride phases that are strictly connected with the macro creep. And but we have to think about what are the time-dependent properties that we can see with indentation test, and that are indentation modules that is strictly connected with the elastic modules and the property of the material, and the linear viscoelasticity. In this case, we are in the case with no plasticity during the applying of the load, and in this case, this is the evolution of the linear viscoelasticity with the time and connected with the penetration inside the material. So we do some experimental validation on polystyrene, and we find out that also with different maximum load and with different time required to arrive at the maximum load, we have the same profile. So this means that the creep compliance does not depend on the loading profile, and it's a material property that can be checked. So the penetration inside in function of the time can be seen that it is proportional to the logarithm of the time, and so means that the long-term creep behavior of the CSH depends only on one parameter, that is the contact creep modulus C. And this means that looking at small scales with nanoindentation test in some way means to looking at large times with a standard macro test. And thank you.